What's going on, guys? We're back. I decided to record this one even though it's 11:26 at night. I don't want to be a bad tenant, but we just did the craziest thing of all time. Are you ready? We beat the entire world in memory. All right? 100th percentile, dude. Let's go. All right, it's a medium Leetcode of the day. It's called XOR queries of a subarray. All right? So if you look at the problem, it gives you an array of numbers, and then it gives you different queries that you have to run. So this one is index 0 all the way to index 1. So it'd be the XOR of 1 and 3. Okay, this one is 0 to 3. So it'd be 0 all the way down to here. All right, so it's going to be 1, 3, 4, and 8 all XOR together. Okay, and then if they are the same, then it's just the XOR of that, of that position, which as you can see is just a repeat. Now, when I was solving this, I thought about like how you're repeating a lot of work because you're XORing things that you already XORed. Like for instance, you're doing 0 and 1 here, you're gonna have to do 0 and 1 again. You do 0 and 3, right? Because you're gonna go 1 XOR 3, 1 XOR 3, XOR 4, XOR 8. Okay, so what I did here is I employed the prefix sum solution, and it worked pretty well. It worked pretty well for sure. So I started by just prefix summing the entire array of numbers here, and we go from left to right. All right. So we're going to skip the first one because 1 XOR by itself it's just the same number. There's no point in doing it, right? Or it isn't. I don't know. There's no point in doing it because we just want to know what is the value of, like if we have 1 XOR 3 XOR 4, 1 XOR 3 has already been solved because we're going from left to right. So we would just make 4 XOR the number right here. Okay, so we're going to skip this one and we're going to start here. And this value is going to be XORed by this, the one to the left. All right, so that's what we do in this first array. Super simple, super simple. Okay, and then once we make that prefix sum array initialize, again, using the space of the original numbers array, then we go through each of the queries. We get the left and the right numbers, okay? Right here, like the 0 and the 1 or the 0 and the 3, okay? That's going to give us our range. Now, as long as your left number is not 0, you can always just grab your left can just be, like if it was 1 to 3 right here, you're just going to XOR the number right here, XORed with your right number, okay? Because if you look at a Venn diagram, XOR only gives you the numbers that are not in both, okay? So to do that, you need to get the 1 over to the left so that you can just get this little bunchy bunch right here, right? So that's why we do the left minus 1 XORed with the right. But if the L is 0, then you can just grab all the numbers in the right because you can't go outside of the bounds, right? And there's no point because it wouldn't have a prefix sum for the XOR, right? So yeah, it's pretty simple. It's a beautiful, elegant solution. And as we can see, 100 percentile memory. Runtime, I don't know how to improve it, all right? We're right in the ballpark. I don't know how people are here doing that. Good for them, all right? That's all. I gotta go to sleep so I can wake up and work at Chipotle and then go do Uber Eats. Grind life until the programming job starts at Capgemini Government Solutions. Let's go. This is the most embarrassing part, is trying to find the stop button. Bye-bye.